Today we're going to study factoring, and we are going to factor perfect square trinomials of this form: x squared plus or minus 2xy plus y squared. First, let us review our special product, the square of the binomial x plus y. And the answer is a trinomial x squared plus 2xy plus y squared. Also, if we have the square of x minus y, the answer is a trinomial x squared minus 2xy plus y squared. This trinomial and this trinomial are called perfect square trinomials because both of them comes from the square of binomials. For today's lesson, we are going to have the reverse process. The problem will come to you as this product, and you will be required to provide factors, which is the square of binomial, either of this form or this form. How to factor perfect square trinomials? We are going to follow these 3 steps. Step 1, check if the trinomial fit the pattern of the perfect square trinomials, either this form x squared plus 2xy plus y squared, or this form x squared minus 2xy plus y squared. In step 2, write the square of the binomial. And step 3, check by multiplying the factors. Let us have example 1. Factor the trinomial 25x squared plus 20x plus 4. Let us check if this trinomial is a perfect square trinomial. First, our 25x squared and the number 4, we can rewrite it as the square of some terms. So the 25x squared is now the square of 5x, and the number 4 is 2 squared. For the middle term 20x, what we will do, first, let us write the 5x in here and the number 2, and these are the bases of the first and the third terms respectively. And then we will multiply by 2. And this number 2 is always constant. When we multiply these 3 factors here, we are hoping that the answer will be the middle term. So 2 times 5x times 2 will give us that positive 20x. So it means to say this given trinomial is a perfect square trinomial. We can now proceed to our step 2, write the square of the binomial, and that will be our answer. So to write our answer, we're going to put 5x as the first term here, and that 5x is the base of the first term, and then plus this positive sign comes from the sign of the middle term, and the number 2, and this number 2 is the base of the third term. And then we will not forget the square outside. So this is our answer, the square of 5x plus 2. Now for the step 3, we're going to check our answer if it is correct. We are going to expand and hope that we will get back our original problem up here. So when we expand a binomial, it will follow this pattern here. So the 5x square, it will give me the 25x square, and that is the first term of the trinomial. If I square 2, that is equal to 4, and that is the third term of the trinomial. Now I will multiply 5x times 2 and times 2, and that is equal to 20x. So the square of 5x plus 2 is our final answer. Let us go to example 2. Factor the trinomial 16x squared minus 8xy plus y squared. I wrote my steps here. So first, I'm going to rewrite the 16x squared into the square of 4x and the y squared to be the square of y. For the middle term, first I will write the minus sign, and then the 4x and the y are written in the middle, and then times 2, and that is a constant. And I will hope that if I multiply 2 by 4x and by y, it will give me that 8xy. And it is. So it means to say this trinomial is a perfect square trinomial. So the pattern is satisfied. I can now go to step 2. I will now write my answer. And my answer, or my factors, is the square of the binomial. So I will collect the 4x. I will put it here as the first term of the binomial, and then minus. The sign comes from the sign of the middle term, and the second term here is the y, which is the base of the third term. Of course, I will not forget the square outside. So this is my answer, the square of 4x minus y. Going to step 3, I will check my answer if it is correct by multiplying the factors. Or I can say that I will expand my binomial. If I do that, it will come to this pattern. So if I square 4x, it will give me 16x squared, and that will be the first term of the trinomial up here. If I square negative y, it is equal to y squared positive, and that is the third term of the trinomial. Now, I will multiply 4x by negative y and times 2. That is equal to negative 8xy. So, my answer, square of 4x minus y, is correct. And that is my final answer. Let's have example 3. Factor the trinomial 100x squared y minus 80xy plus 16y. I can see here that the first term and the last term are not perfect squares. So I can say that this is not a perfect square trinomial. However, I can see that there is a greatest common factor among the three terms, and that GCF is 4y. So I will factor out the GCF, and for the first term, when I remove the GCF, what remains is the 25x squared. For the second term, what remains is the negative 20x. for the third term, what remains is 4. So it means to say, I have now a new problem here. 4y times a trinomial 25x squared minus 20x plus 4. Now, I will check if this new trinomial is a perfect square trinomial. I will rewrite 25x squared into the square of 5x and that 4 to be the 2 square. In the middle term, first I will copy the sign, the negative. Then I will take this 5x right here. I will take this 2, put it here, and then times 2. If I multiply the 2 times 5x times 2, this will be equal to the negative 20x. So it means to say, this is a perfect square trinomial. Of course, I will not forget my 4y to be copied down here. So I will now go to step 2 to write my answer, to write the square of the binomial. First, I will copy the 4y, and then for the binomial, it will be the 5x as the first term, then minus, the sign comes from the sign of the middle term, and then the second term is the number 2, which is the base of the third term. Again, I will not forget the power 2. So this is my answer. 4y times the binomial, or the square of the binomial, 5x minus 2. Now, for step 3, I will check if my answer is correct. First, I'm going to expand the 5x minus 2 all squared. So the 5x squared is equal to the 25x squared. It is written here. If I square negative 2, it will be positive 4. I'm going to multiply 5x times negative 2 times 2. It will give me the negative 20x. And the 4y here, I can write it there and then start to multiply the 4y to each term of the trinomial. And it will give me this original trinomial 100x squared y minus 80xy plus 16y. So I was able to confirm that my answer here is correct. And this is my final answer. Example 4. Factorize 36x squared minus 84xy plus 49y squared. We're going to check if this trinomial fit the pattern x squared minus 2xy plus y squared. First is, we're going to show that the first and third term are squares of some terms. We will rewrite the trinomial and it becomes like this. The 36x squared we can write as square of 6x, while the 49y squared we can write as the square of 7y. Next is, we're going to multiply the bases of first and third term times 2 if it equals the second term. Let us rewrite the trinomial down here. So the base of the first term is 6x, we write it here. The base of the third term is 7y, and it is here, then times 2. Now, we're going to simplify 2 times 6x and 7y, if it equals 84xy. And the answer is yes. If pattern is satisfied, we will now write our factors, and that is the base of first term minus the base of third term, that is squared. So 6x, this is the base of the first term. Then minus, the base of the third term is 7y. And then we square. This is now the final answer. And we will factor difference of two squares, and this is the form x squared minus y squared. Let us make a review for special product. When we multiply x plus y times x minus y, the answer is a binomial x squared minus y squared. The factors are called conjugates. It means the conjugate of x plus y is the x minus y, and vice versa. While the product, we call this difference of two squares. For today's lesson, we are going to do the reverse process. The problem will come to you as this product, and then you are required to give the factors of this form. How to factor difference of two squares? In step 1, rewrite the two terms as squares of some terms. Step 2, write the factors following the pattern. The x squared minus y squared equals the binomial x plus y times x minus y. Let us have example 1. Factor the binomial x squared minus 9. For step 1, we will rewrite the two terms as squares of some terms. So the x squared is now written as the square of x, and then minus the 9 is now 3 squared. For step 2, we're going to follow this pattern. It means we expect two binomials in our answer. But take note that the signs must be different. One is positive, the other is negative. We're going to put x on the first blank of the binomials. And then the 3 will be the second term of each of the binomial. So we see here we have the x plus 3 times the x minus 3. So this is our answer. Let us have example 2. Factor 64y squared minus 1. Again, we are going to rewrite these two terms into squares of some terms. The 64y squared can be written as the square of 8y, and then minus the 1, we can write it also as the square of 1. And then for our answer, there will be two binomials. In the first term, it will be 8y, also 8y in the first term of the second binomial. And for the signs, it must be opposite. One is minus, the other is plus. In our answer here, the negative comes first, followed by positive. And it doesn't matter as long as the signs are different. Now for the second term, we copy that 1. So it's now placed here and also in here. So our answer is the binomial 8y minus 1 times 8y plus 1. This is our final answer. Let us consider example 3. Factor the binomial 48x raised to 4 y square minus 75 y square. The terms are not perfect squares. We can see here that the variables are perfect squares. However, the coefficients are not. Therefore, these two terms are not perfect squares. But remember, we can check for greatest common factor of each term. I found out that the GCF is 3y squared. So if I pull out that greatest common factor, this first term here will become 16x raised to 4, while the 75y squared will be 25. Of course, the negative sign we will just copy here. So for our problem here now, we have monomial times binomial. And then we will check if this binomial here have terms which are perfect squares. The 16x raised to 4, we can write this as the square of 4x squared and then minus. We know that 25 is a perfect square number, so that is 5 squared. And then we will just copy that 3y squared down here. And then we will have the step 2. For step 2, we are now expecting two binomials here. The first term will be the 4x squared. It's now here and also here. And then for the signs, we will have the plus and minus. And for the second term of the binomials respectively, it will be this number 5. It's now here and also here. So our final answer is this 3y squared times the binomial 4x squared plus 5 times the binomial 4x squared minus 5. And this is our final answer. Today we're going to do factoring. We will factor sum and difference of two cubes. And this is the form x cubed plus or minus y cubed. First, let us review our special product when we multiply binomial times trinomial of this form. So x plus y times x squared minus xy plus y squared. The product is x cubed plus y cubed. Our product here is related to our binomial factor. It's like we take the first term of the binomial factor, put it here, and then put a power 3. And then the positive sign is copied here. The second term y is written here and then power 3. So let us analyze the trinomial factor. The first term of this trinomial factor is the square of x, and the x is actually the first term of our binomial factor. The y squared is the square of y, and that y is the second term of our binomial factor. The middle term is the product of these two terms, in the binomial factor x times y. But on the pattern, we should write the opposite sign. So our special product here now is the sum of two cubes. Also, when we have the x minus y times x squared plus xy plus y squared, the answer is x cubed minus y cubed. And this is the difference of two perfect cubes. The pattern is the same. The binomial factor is related to our product. The first term x is placed on the product and with power 3. And then minus. Take note that our sign here is the same with our sign in our product. Followed by the y is placed here and then with power 3. For the trinomial factor, the first term x squared comes when we square the first term x in here. The last term y squared comes from when we square the negative y. It will give us positive y squared. The middle term xy comes when we multiply the x times the negative y. We get a negative xy, but based on the pattern, we should write the opposite sign. So you see here in the middle, it is positive xy. For today's lesson, we will do the reverse process. The problem will come the sum of two cubes or the difference of two cubes. And you will be required to provide the factors of this form or of this form. How to factor sum or difference of two cubes. We are going to have these three steps. Step 1, write the terms as cubes. Step 2, use the sum or difference of cubes pattern. And the patterns are here. And step 3, simplify. Let us apply these steps to solve some problems. Let us have example 1. Factor x cubed plus 64. The steps are here. So we will apply the step 1 first. Write the terms as cubes. So x cubed here is now written as the cube of x and then plus the 64 is equal to the cube of 4. And then step 2, we're going to write the factors. In the factors, we expect a binomial times a trinomial. Let us write the binomial first. We will write the x, we will copy the positive sign, and we will copy the number 4. So our binomial is the x plus 4. For the trinomial, the first blank is the square of this x. So I write here the square of x. The last term is the square of the number 4, or the second term of the binomial. In the middle term, I am going to multiply the two terms here. So x times 4. But take note that we will use the opposite sign. So all the terms are now in place. We will just simply go to step 3 to simplify. I will copy the binomial, and then for the trinomial, I will simplify the square of x to be x squared. The middle term becomes negative 4x, and the 4 square is now written as 16. So this is our final answer. Let's have example 2. Factor 8x cubed minus 27y cubed. Let us first write the terms as cubes. The 8x cubed is now the cube of 2x, and then minus. The 27y cubed is now the cube of 3y. Step 2, we will write the factors. Again, in the factors, we expect binomial times trinomial. Let us begin with a binomial. I will now copy the 2x, and then the negative sign is copied here, followed by the second term, and that is the 3y. So our binomial is 2x minus 3y. For the trinomial, the first blank is reserved for the square of 2x. The last term is reserved for the square of this negative 3y. Look at the middle term. I'm going to multiply the 2x and the negative 3y here, but later we should write the opposite sign. If I multiply a positive by a negative number, of course the sign will be negative, but based on the pattern, I should write the opposite sign. So going to step 3, I will now simplify. First, I copy down here the binomial factor. For the first term, the square of 2x is now 4x squared. For the middle term, I multiply the 2x times the negative 3y. It will be negative 6xy, but I should write the opposite sign. So this is plus. The square of negative 3y is now positive 9y squared. So this is our final answer. Let's have example 3. Factor negative 2x cubed y squared minus 16y raised to 5. We can observe that the terms are not perfect cubes. But remember, let us check for greatest common factor. I observe that the GCF is the negative 2y squared. So when I factor out the GCF, the first term becomes x cubed. The second term becomes positive 8y cubed. And from here, we can now apply our steps in factoring sum of two cubes. Let us write the terms as cubes. So first I copied the GCF, negative 2y squared, and then the x cube is now written here as the cube of x. For the 8y cube is now the cube of 2y. Now let us go to step 2. Let us write the factors. We expect binomial times trinomial. So in our binomial, let us now write the x followed by the positive sign followed by the 2y. So our binomial is x plus 2y. For the trinomial, the first term is the square of x. The last term is the square of this 2y. The middle term is the product of the two terms of the binomial factor, but we should write the opposite sign. So all the terms are now in place. We will now simplify. I copied first the GCF followed by the binomial factor. Let us simplify now our trinomial factor The first term is now x squared. The middle term is now negative 2xy. And then plus the square of 2y is now 4y squared. So this is our final answer. Problem 1. Factor completely using the perfect square trinomials pattern. We have our special product here. Let's have letter A. 25v squared plus 20v plus 4. Note that the first term is a perfect square number that we can write the square of 5v. For this third term, the number 4, we can show that this is 2 squared. Then we multiply this 5v in the middle and this number 2 and then times 2. When we multiply 2 times 5v times 2, the answer is 20v. That means these three terms follow the pattern of our perfect square trinomials. And in the product, we will write like this: 5v plus 2 with power 2. The 5v is the base of the first term, the plus here is the sign of the middle term, and the 2 is the base of the third term. Trinomial B, 36s squared plus 84s plus 49. The first term and the third term are all perfect squares. We can show that the 36s squared we can write as the square of the quantity 6s, and this 49 we write as 7 squared. Then we take the 6s times the 7 and then times 2. Let us check if this equals the 84s, and indeed it is. That means the three terms here follows our special pattern. And the product will be 6s plus 7 with the power 2. The 6s comes from the base of the first term, and then plus, and 7 comes from the base of the third term. Trinomial C, 64x squared y minus 96xy plus 36y. Note that the first term and the third term are not perfect square terms. What we can do here is to check if there is a common factor, and the GCF is 4y. So we pull it out, multiplied by the trinomial 16x squared minus 24x plus 9. Now, with the trinomial here, check that the first term is a perfect square term, and also for the third term. In here, note that the middle term is negative. That means we're going to use the other pattern, this x squared minus 2xy plus y squared. And the special product is this on the right side. Now, let us show this 16x squared to be the square of 4x. The positive 9, we show that this is 3 squared. Then we take this 4x and then this 3 multiplied by this 2. And we have this negative sign in the front. When we multiply 2 by 4x by 3, we will get this 24x. That means this trinomial follows this pattern. Finally, the product will be this 4x minus 3 with the power 2. Of course, we copy the 4y. We know that this 4x comes from the base of the first term. Then minus, this 3 comes the base of the last term. Problem 2. Factor completely using the difference of squares pattern. This is our special product. We have x squared minus y squared equals x plus y times x minus y. Let's have expression A. 36p squared minus 49q square. We can check or represent these two terms as a square of some terms. The 36p square we can write as the square of 6p minus this 49q square we write now as the square of 7q. So we can use our special pattern. So we have 6p plus 7q times 6p minus 7q. This is the answer. Or we can write the first term to be minus, the second term to be plus. Expression B. A square plus 6a plus 9 minus 9b square. In here we can see that we have four terms. But look closely. The first three terms we can group together. Actually, we can factor this out. And this is of the form of perfect square trinomials. That means we can factor this out as the square of a plus 3 minus 9b square. Now let us represent this 9b square as the square of 3b. So we have two perfect squares and this is minus. We can now use our special product. So we have a plus 3, 3b times the group a plus 3 minus 3b. Problem 3. Factor completely using the sums and differences of cubes pattern. Here are the patterns. Let's start with A. 125 minus 27w cubed. Let us represent both terms as perfect cube. This 125 we can write as the cube of 5. Then minus, for 27w cubed, we write here the cube of 3w. And for this, we're going to use the second pattern. This is difference of two perfect cubes. In the answer, there will be a binomial times trinomial factors. In the binomial, we will write 5 minus 3w. Simply we copy this 5, the base, then the minus sign, and the base of this, that is 3w. Now for the trinomial, we take this 5 and we put power 2. For the last term, we put this negative 3w with the power 2. In the middle term, we multiply the two terms, 5 and the negative 3w. However, we should use the opposite sign. When we multiply this 5 with negative 3w, the answer will be negative. Using the opposite sign, we should write here positive. Then let us simplify the trinomials. So we have 5 squared is 25, plus 5 times 3w is 15w, plus the square of negative 3w is positive 9w squared. We simply copy the binomial factor. Expression B. 7k cubed plus 56. Note that these two terms are not perfect cube numbers or terms. First thing we do is we check for a common factor, and that is GCF is 7. When we pull it out, what remains here is k cubed plus 8. And from here we can see that 8 is also a perfect cube number. So that means representing this 8 to be 2 cubed and then plus the cube of k for the first term. We will now use our pattern. We copy down the number 7, and for the factors, there will be a binomial times trinomial. For the binomial, it will be k plus 2. We know that we copy this base k, and then the plus, and the base 2. For the trinomial, in the first term, we write this k with power 2. On the last term, we take this number 2, then we write power 2. In the middle term, we multiply this k and 2, but we should use the opposite sign. So this will be minus k times 2. Finally, we simplify this trinomial. So we have this 7. We copy the k plus 2. This square of k becomes k squared minus k times 2. We write here 2k. And then 2 squared is 4.